Okay, so can everybody hear me? So I'm going to be talking about Keykit's piece of software I've been working on for actually over 15 years. It's evolved quite a bit over the years. I'll just to get a sense of what people are interested in. How many people are interested in the language, you know, the internals of the system? Okay, and I assume the other people are not. So I was going to split it in half, so that looks like a good balance. So basically, this program implements an interpreted programming language. It's multitasking, has GUI. You'll see a lot of that. The entire purpose of the language from day one was MIDI, real-time stuff. So that's what it does best. The interpreter is tuned to that application, so the innermost interpreter loop has all sorts of real-time hook and so on. I wrote it back in the days of 20 megahertz or 10 megahertz, 68,000s, 386s. So I get very efficient back then, which means that nowadays with modern CPUs, it's blazingly fast for MIDI operations, and that's allowed me to do larger things. So it'll throw around thousands of notes quite easily. Like developing for fun. This isn't a commercial product, but it's freely available on the website. So it started really simple. I had real-time stuff, graphics, then one failed attempt at multi-window stuff. My second attempt at that got right. For the last 8 years or so, the language really hasn't changed much. So it's quite stable. Over the years, I've ported it to all sorts of different machines. So it's an interpreted programming language inspired by awk, which means there's no semicolons, you don't have to declare variables. And for MIDI is a first-class data type, and it looks like a structure, so you can refer to attributes of the MIDI phrases using this structure notation. This data type, every note has pitch and duration. These operations let you merge MIDI phrases very easily. You can cut the phrases apart, do filters on using these kinds of expressions. You can loop through them very easily. Awk is a very C-like language, so it's very familiar if you're used to C. It has locking for real-time stuff, so it's multitasking, so you can have typos sending things between tasks, and you need locking between them. More recently, I added TCP/IP hooks, so you can do network kind of things. It's been portable over the years. There's a Mac version, but it's not really well supported. The TCP/IP hooks only work on Linux and Windows. So for MIDI, it's real time. It's constantly monitoring MIDI input. So whatever you're doing on the keyboard, you immediately use that, grab it, and pull it in. I'll show examples of that. Let me just skip over the words on the GUI. I'll show the GUI, obviously. I built it for myself to write algorithmic MIDI software, and after about 8 years or so, I stopped changing the language and started actually using it. So I use it kind of in an improvisational way, which in the end result is lots of different weird tools. Because it's an interpreted system, it's very easy to make changes on the fly while the system's running, and so I'll add features. A lot of the tools, a year later, I have no idea what they do or how to use them if they didn't turn out right. So some tools turn out well, and I keep enhancing them. Others are failed experiments, and I forget about them. So here's some of the more conventional ones. Drum pattern editor, some continuous controller stuff, traditional sequencer. These are some of the weirder ones. Roller derby to oscillating controller values. This is kind of a techno tool. Okay, so it's turned out pretty well. The key is that it's built for me, so, and phrase is a fundamental type that you can throw around quite easily. That's been a big win. The fact that it's an interpreter is a big win. Associative arrays have been very powerful. And I'm a programmer, a traditional programmer, so a procedural programming language is what I'm used to, hence that's what I build. So for me, that's an advantage. To other people, that's not an advantage. So it all depends on what kind of programming you want to do. And as I said, it's freely available at that website. Okay, so let's get into some of the tools. Let me talk a little bit about the basics of GUI. I use it as an exploratory thing for GUI, window system exploration. So there's pop-up menus like this, and message menus and so on. Every menu can be pulled off. And one of the more unique things is that every button in the system, no matter where it is, in any menu message, you can, rather than invoking the button, I'm not going to let go on the mouse, I'm going to drag it off, and that button can be placed anywhere. So any menu, anywhere in the system, you can do this to. And that's a huge win for some things. In particular, here's the multi-track sequencer. Read some music here. I can highlight these notes, and then this menu here contains a whole bunch of algorithmic editing operations. And some of them are very deeply nested. So let's say I want to do a lot of quantizing. So if I want to do a lot of quantizing, I can just pull off this menu. Or if I'm going to do a lot of quantizing by quarter notes, I can take this quarter note item and drag it off. So you can build up the things you're using, into essentially custom. When you think of the toolbars, the problem with in this environment with the toolbars, there's so many operations you can't predict ahead of time what operations you're going to be using. So this is kind of like an on-the-fly creation of a toolbar. So I won't show more conventional things. This multi-track sequencer is kind of a traditional thing with lots of editing operations. But here I'll tend to show the weirder ones. So it's Espresso tool. Takes some expressions this uses an L system algorithm to generate large expressions. This is the set of transformations. It starts with a very simple expression and then applies these transformations to it repeatedly. The end result is a very long expression, and all in terms of a single variable x. And all I do is substitute a phrase for the variable x and evaluate the expression, and it turns into a very complex result. bottom there is the expression that resulted after 9 iterations of the algorithm. When I'm using this kind of thing, you can see it's very quick on generating a new one. So I'll just generate stuff. If it looks visually interesting, I'll play it. And if there's good stuff, then I'll copy it to another tool. All these individual tools work together through the Windows system. Every one of these tools is an object with common methods for get and set. So any tool that implements get and set of a phrase you can essentially copy things between them. So I can say window copy from there to there, and these two tools didn't know about each other, but I just did a get from this one and a set on that one. So all tools can be used together and are intended to be used together this way. I also tend to have dozens of these little windows on the screen at a time. Every tool can be resized, to any size. There's also pages, so I can switch to a new page. And put some tools there, switch back to the first page. I can also grab entire tools. One of the common methods of these tools is a dump and restore method. You ask a tool to dump itself, it'll give you a string, a huge long string that contains its entire state. You can then, if you instantiate another instance of that tool and do a restore with that same string, it'll restore it. So I can say window snarf tool, that tool. I just snarf the dump of that tool. And now I can say paste that tool there. I can paste it to the other page. I've also used that with the TCP/IP connections. You can have 2 instances of the system running, and you can actually broadcast tool to the other side. So having these common, a very small number, half a dozen or so common methods of these tools, especially the dump and restore, gets used for saving the entire state of the page, copying things between pages. Let me play a piece. This is a piece using that tool. I kept writing lots of stuff, little pieces I liked, and I pieced them all together. So a lot of examples I show may not sound very musically great. These are all intended largely to generate ideas and stuff. You can force them to more musical things. I can force all of the notes to fall on a given scale and so on. So let's. So that particular L systems thing has been one of the tools that I've gotten a lot of use out of in a variety of different forms. There's some interactive things on my website that use that for the generation. This screen, I used it as a Woodstock 2000 thing in a real-time performance. Here you can see the screen that my PC was showing when I was doing performance. There's 8 instances of the expressive tool there, and I was using that, with the mouse and changing them on the fly and playing them. Okay, another tool is called Geekiest. The original idea for this came from Tim Burkus. He gave me the meme. Basically, if you decompile, kind of disassemble notes into small instructions of following form. Set the pitch, increment time, decrement the pitch, increment the volume, and so on. You can take a phrase and reverse compile it into a sequence of instructions.
It's getting pretty tight in here. Do you think just kind of push back a little bit, maybe make a little more room? Filling up the doorways.
Sequence of instructions, and then start, mixing them, and then re-evaluate them. You get new stuff. So this is a user interface for controlling that. Every cell here, it has the instructions to generate that phrase in that cell. You decide which one you want to kill. You kill that one, and it'll take the other cells, mate 2 of them, mix their instructions, and produce a result. Here's that. So I can either fill it with kind of random instructions, or I can fill it from a file, take every few beats of the MIDI file. So if I don't like that, I hit the right mouse button and kill it, and it remakes it. So it's very quick, and you can, kind of guide the generation. Here's an example of that one. Here's another one taking RGB values from a picture. This tool lets you draw a line through the picture. It'll take the pixels along that line, takes the RGB values along that line, and converts it into phrases. One of the problems with algorithmic music is if you just let the system generate the entire thing all sounds the same. So in order to give some structure to it, I built this thing I like to piece together things that are algorithmically. So the top 2 rows there control one phrase with one line through the image. The next one is for a different line through the image. So this lets you interactively explore, drawing lines through the image and construct a piece. So these buttons here are letting me control quantizing somewhere here. I think there's a scale. So on that piece, as you can tell, was much more tonal, and I was forcing it into particular patterns, and also repeating them.
Is that on the left or right of the picture?
It's actually I draw a line anywhere through the picture. So these two rows are some line through the picture. One I'm not showing that interactively is that because it's an interpretive programming language, there's a lot of pixels here, and this is one of the things it doesn't do particularly fast. But still does it surprisingly fast. Okay, so another one I've gotten a lot of leverage out of is called Typo, doing real-time looping. Okay, so I started this. This tool, evolved a lot. I started out being completely keyboard controlled by keyboard. Keyboard, I mean the QWERTY-keyboard. So every key press I hit here, doing a note, I can change channels by pressing number keys. Like doing entire performance from here, and I can do looping. So if I play some notes, if I hold down the Shift key, it now records them. And I hit Enter, and now it's going to loop them. If I can play other things along with it, if I don't hold down the Shift key, it's not recording, but if I press the Shift key, it'll start adding things to the loop. Drums are algorithmic generated. It's kind of a cheat, but
Algorithmic is a big person. Are they based on what you play, the drum?
no, drums are generated by this completely independent algorithm. So I started that, and there's all sorts of different operations, like you can fractalize notes. So I started adding lots of different controllers to control that. I like that, but there's no. If you see people performing, the keyboard is very compelling. So I started playing around with these PlayStation dance pads. There's a USB PlayStation box. You can take any PlayStation peripheral and it'll look like a joystick through Windows. So that lets me, all I did to Keykit was add a joystick interface. Now I have access to all these peripherals. So the other thing I got was a wireless QWERTY-keyboard. So now I do performances where I have two of these pads, and this keyboard, and I do the entire performance like that.
Go for it.
Come on.
Maybe at the end of the night. But so there's lots of controls. I mean, every key. One of the nice things about the QWERTY keyboard for killing is that there's letters, and I can have mnemonics for what they do. So I have every pad has a set of notes. So I can start with one note on that pad. I can increase the number of notes.
What's generating? There's like a clock going on there. Da 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 da. Is that?
Yeah, I mean, everything's quantized to start at every beat or so. So that makes things more accessible. The loops are quantized. I can control the length of the loop. At 26 mix on Mission, they have, and actually, I guess we're going to be playing in Berkeley at SINMAT, STN-MAT, June 21st, Saturday. A group from Santa Cruz, the Woodstockhausen people, that's a really fascinating music event every year in Santa Cruz. So we have a group of people who do circuit bending, taking toys and making strange sounds. So I got involved with them, and I use toys, but I do a performance with this. So TCP/IP stuff. As I mentioned, you can broadcast a tool just by sending the string that reconstructs the tool to the other side. I've also played with real-time synchronization between two sides. I don't try to synchronize them perfectly in real time, but offset by a certain number of beats. So this side is continuously sending stuff to the other side. The other side will resynchronize its local clock, but a few beats later. So if you're playing like a 4-beat pattern, you can jam together. But if one guy changes a key, the other guy won't hear it for a few beats, and vice versa. Okay, so this shows the, if you want to play around with this PlayStation USB interface, I played with, there's quite a few of these, amazing number. I don't know why there are so many, but not all of them, in fact most of them don't work very well. So it took a while to find one that was actually robust and the driver was good and so on. But this one good. And I connected up to 8 pads simultaneously. The other thing I can connect is these are wireless PlayStation controllers. I'll show them in a second. So I'm playing that. So last year, Burning Man, at my site, I had at one time 8, usually I had 6, and people would come and play on them and make all sorts of strange noise. This year at Burning Man, I'm building this monstrosity with 4 dance pads, on the ground. That's a 9-foot high lyre. All the strings are light ropes. They're going to be they are independently controlled from a set of controlled relays. And so as music is being played and generated, the strings of that harp will be lighting up in patterns corresponding to the music. So I've been building it for the last couple months, and it's pretty cool. Last year at Woodstockhausen, I performed on the pads, taking a piece of Bach and breaking it up to sections and playing it from the pads. During that piece, in order to make it more visually interesting, I outlined my pants in eel wire, and they turned out all the lights, so all you could see on stage was these ghostly legs dancing around on the pads. Stick there. This shows I had fairly complex controls, so you could actually control the stuff directly from the pads. I didn't have this wireless keyboard at the time, so everything was controlled from the pads. And that's what the thing did. When I took it to Burning Man, I had the same setup. The problem is people didn't know what to do, and they're pressing all the wrong things. So that was a relative disaster. But I had to change the software. This night it worked okay. The other thing I've been playing with is video input. So USB has been a godsend for me with being able to interface all sorts of stuff. So here's a USB webcam, and
Pointing at the projector so it sees out.
yeah.
Feedback.
So I started playing with this. It's hard to control, to make a really controllable thing. It's good for generating random stuff. But when I was developing, I'd have the camera on my desk, and I'd walk away, and all of a sudden I hear some sound. It'd be my cat walking by, or it'd be seeing the TV. And
Can you map, like I did at Grid, or can you map different things to different areas?
yeah, this, so I can say, read from a file. So I just read that MIDI file, and it took like the first beat or so and assigned that to the first cell, upper left, second beat to the second cell, and so on.
Pixel bar gets above the threshold.
Exactly. So you can hear some less.
So it would be coolest to point that at dark background and have a raised pointer on the dark background to play the various paint a grid on the wall.
Right. Yeah.
So what's the delay there? Is that the code, or is that the USB bus?
Try USB.
No, the delay is, when it's looking for threshold, I can, if I want to make it really as responsive as I can, I'll be able to get it down to, maybe a quarter of a second. So, again, because Keykit's, it's not an image processing program, and there's lots of pixels. I do a lot of averaging of the pixels down in C code and then send them up. So I was able to I can get pretty response stuff, within a quarter of a second or so to react to things visually. But it's still hard to do things in a repeatable way. So I haven't really explored too much more than this. or maybe next year. So this is one of the ones that kind of develops iteratively. So I was working on this video thing, and I essentially wanted the cells in that video thing to act to like agitate balls, you know, going around. So I built this thing with balls that can bounce around, and I have the I connect the video thing to that to drive it. But in debugging it, I needed something more direct. I started, you know, using a mouse to control them. It's a lot more fun to directly, you know, poke the balls. So, and especially from a wireless thing. So there's 3 colors of balls: red, green, and blue, which I can control from these 3 buttons. So I hold down this one button, the red one's bouncing around. I can add more red ones. There's the green one, I can add more green ones. Blue. String sound. If I hold down this other button, when the balls hit a wall, it'll start breaking them down. I can also, with the mouse, actually cut down walls manually, so I can construct mazes, you know, the balls go through. Every wall, you know, has a phrase associated with it. I can read, you know, from a MIDI file, so I can generate either, you know, random music or tonal music. And you get a lot of repeated things, or you can, because you got a maze. Obviously, with the cell, it's repeated, but you can have, you know, a series of a few cells that's bouncing around. So you get a lot, and repeating is a very musical thing. And from here I can change patches and so on. So I can do a whole performance from this.
A few more seconds of it. Can you show us more open space? So in other words, as this.
Oh, so I can, with the joystick, I can direct the balls. I can.
These 2 balls meet and they create.
So you got the idea.
Ball and anti-ball.
So when I have it like that, and to make it more tonal, I can turn on this mapping thing, and now all the notes get mapped to this new age, in this case, new age scale. So,
Versus an old age scale.
yeah, so that, I guess that's